from 5A, what is your y-intercept? Like this one, it looks like B is at 1/2 or 0.5. And then you are finding your slope. And you're counting from the 2 points that they gave you. So you looked at the rise to the run, right? And your equation was going to be the slope, that rise over run, which in this case, in number 9, Haley, what did you have? How far did you go up?
-2 up to 3, which goes +5.
And then how far did you go over? 8. So when we went up 5 and over 8, we write our equation as y equals 5/8 x. Plus, we can see our b is at about 1/2, 0.5, or you could have had a half. Okay? And then those last ones that you were looking at on 5A, again, answers are towards the back, is you were looking to graph it. So you were looking at my start point, the beginning, if we think about 13. The beginning was at b equals -3, and our slope, our movement, was 4/1. So when you looked at those questions, okay? Come in and see me. So today we're looking at making and interpreting our scatter plots. So this is a scatter plot. It's like when I give you a bunch of points and ask you to graph them, okay? You're going to do, that's what you're going to see kind of in your homework tonight as we start looking at these. So a scatter plot is a graph of bivariate numerical data. That's like when we did your height and your shoe size, 2 numbers, okay? We can't do it with categorical data. It says data points are displayed in the coordinate plane as an ordered pair. Most scatter plots occur in the first quadrant because of the real world data. So you're going to see almost everything in quadrant 1, which is where we have positive x and positive y. It says when we look at data in a scatter plot, we can identify many patterns. For example, if the data generally follows a straight line, we call it linear. And if it does not, we are going to call it nonlinear. So if we look at this first one, we would say this is non-linear, right? It does not make a straight line. This is actually like a curve, like a parabola. So right next to that, please write non-linear. If we look at this one, does it look like we could maybe take a straight line or a straight edge and draw a line of that would be kind of in between our data points? Yeah. Someone could have that line. Someone else could look at it and go, you know what, I think the line of best fit would maybe look like this. Someone else might look at it and say, you know what, I think it actually kind of curves like this. So there's many different ones, but this would be very close to linear if we are looking at it. So this one, because we can draw a straight line for our data and it fits, we would call it linear. Other vocabulary that we are going to be looking at on that next screen down in your notes. And it says another way to analyze our data is to look for correlation and its strength. So these are some things we're going to ask you in your homework tonight. Correlation is positive. Both values are increasing. This one is strong positive. As the x increases, the y increases. This one is a weaker positive. Correlation is going to be negative if one value decreases and the other increases. So as the x value, right, so this is our x, as it gets bigger, the y value gets smaller. So it started up here, that's a strong negative to a weak negative. Correlation is strong when the points are lined up almost in a straight line. It's weak if they're kind of scattered and they don't kind of exactly make a straight line, but we still can see that as the x gets bigger, the y gets bigger. As the x gets bigger here, the y is getting smaller. And then this last one, no correlation. There is no relationship between those two. It says usually the points in a scatter plot form a single group of points, but sometimes points form 2 or more distinct groups called a cluster. An outlier is an unusual point in that scatter plot when we are looking at it that does not seem to fit the general pattern. It may be far away from where our other points are. So in the picture down below, you can see for our outliers, we have 2 points that are kind of away from all the other ones. This data looks really strong linear except for these 2 points. So sometimes outliers are going to affect it. Sometimes we're going to include them in our data, other times not. Then when we're looking at clusters is just when we group the data. So there's 2 kind of distinct groups as we look at this. This one would be be positive, but it would be a weak positive correlation, right? So when we were looking at the data here, they were looking at calories per serving and sodium, right? So there's some things that are lower in sodium and still have quite a few calories. Then there's these ones that have a lot of salt and a lot of calories. So you're going to be asked to describe the data. So right now to the side, you see a bunch of words, okay? You need to circle the descriptions that you think fit. So does this look linear? Yeah. So we want to circle linear. It can't be both linear and nonlinear, right? It has to be one or the other. Okay, so now you are circling this. Next question, you want to decide, is it positive or negative?
Positive.
This is positive. As x increases, right? As x increases, the y is also increasing. Strong or weak? I agree. I'd go with strong. Are there any outliers?
No.
No, but there are
Clusters.
There's clusters. Like this is a cluster kind of down in here. Okay. So from looking at that one, what I want you to do is looking at the next three. I would like you, as you look at the next three on here, try and decide and circle the ones that you think and just go through and do those, and then we are going to. You want to volunteer for this group right behind that we are looking at. This one back here. Anyone and their partners want to tell me? Go, Steve. Non-linear looks good. Definite negative going down. Pretty strong. X goes, the Y goes down pretty strong. Outlier, definitely an outlier down here, right? And this would be a cluster up in here. I agree. So we have this cluster and we have an outlier. All right. Looking at the next one over here that we're looking at. The experimental results with the number of bacteria and the amount of sunlight. Someone want to tell me what they and their partner have? Someone else?
Which one?
This one, experimental. You guys want to go?
Yeah.
Okay.
Linear.
Linear. I agree.
Negative.
Negative. Yeah.
Strong.
Pretty strong.
Outlier. Or outlier.
Definite outlier way up here. This one's kind of weird for the rest of the data. Not really a cluster though, right? I mean, it's kind of spread out. There's not like one set group. I mean, maybe kind of in here, but it kind of fits the data. All right, how about the last one before we go to lunch? Someone tell us. Go, Jason.
Linear.
Linear.
Positive.
Positive.
Weak.
Weak.
And clusters.
And definite clusters. Kind of have a cluster here. Maybe a couple more. Really not any outliers as you are looking. So as you look at this next one, kind of doing the same thing that we are looking at. So you are maybe climbing and the temperature, right? So if we are looking at this one, I need a different group. Someone want to tell me what they have? Jake.
Linear.
Linear.
Negative. Weak. Outliers and clusters.
Weak. Outlier is where?
At the top. First one.
This one?
Yes.
Well, if you're going to
The line
draw a
goes that
line
way.
though,
How's it weak?
I think I would go more to the strong than weak.
Okay, well,
Okay. Could you have had non-linear?
yeah.
Yeah.
Because could the shape of this one be like this,
Looks like Florida.
right? That would be not a straight line. But if you said linear and you did this, that would also be okay, right? So for this one, I actually would have taken linear or non-linear, and what you'd want to show me is the pattern, right? You'd want to draw the line, either show me the straight line or the curved line. So I would take either one here. I would say strong, and I don't know that I'd say outlier, but do you see any clusters?
Yeah.
Like kind of this area down in here, right? Definitely clusters. All right, let's go down to that next one down. If we are looking here, we're looking at Old Faithful eruptions, okay? So we are looking at the eruption time and the time between eruptions. Anyone ever been to Old Faithful? Okay, so,
Is that a super cool thing?
so, someone want to start me off? Kind of want to go?
I'll give you the
Sure.
Positive, linear.
Linear,
Positive,
positive,
strong.
strong, pretty strong, I'd say. But there's many different lines that people could have drawn, right? But you kind of want to keep it in the middle. Okay, keep going.
And then out, clusters.
And cluster.
And do the outliers in the middle?
Nope.
Well,
if you go through the middle,
there'd be a couple of
Outlier is something like way up here. That one's a definite outlier. Okay? Way away from the rest of the data. So this next one, linear or non?
non-linear.
Kind of, right? Like that, almost. It curves. And again, by showing the curve, that's going to help you see. This one is definitely positive. It goes up. It's, what would you say, strong or weak? Kind of weak because of this whole area, and then going up, it's not the strongest. It doesn't give an exact definite pattern. And do we have a cluster?
Yes.
Kind of this area down in here. Okay. And what did it say if you look at one like this? What are you supposed to do?
Circle everything.
Circle nothing.
What?
Right? At the top it says, and if there is no correlation, if there is no pattern, circle nothing. This one, you can't tell if it's linear or not, positive, negative, strong. It's none of them. It's no relationship. Which do you think shoe size and your IQ should be related?
Yes.
So that the bigger your foot, the smarter you are, the smaller your foot. Okay.
I found like 16 sandals. I'd be some,
So, here's what we're going to look at. I want you to, on the top of the next page, to plot these points. So, we want to put a scale on the bottom. Dollars spent, right? So, on the bottom, please write down here dollars spent. That's going to be our label. Our dollars spent are our X. We are going to go from 1 up to 15. So we're looking at $1, 2, so put your numbers down below, please. And as you are looking at your Y, so this is our dollars. This is the gallons, is our Y. So the number of gallons that you bought. And notice that the gallons that you bought goes from a low of 1.1 up to a high of 3.3. So, if we are looking at our gallons, we might want to have 1 gallon, 2 gallons, 3, and we don't ever go up to 4 gallons for this one, right? But this is our gallons. Are any of you need to buy your own gas for your vehicles?
Yes.
Okay.
So, or your moped, right? So,
I don't.
please plot the points. At 10, 2.5, right? So 10 to 2.5. You're going to put points. 11, 2.8. 9, 2.3. So continue plotting those points. Okay? You're going to plot all of those points. They're just going to be a little point when you put them up there, right? So each one just put a point. I like their writing better than mine. It's a little neater for you to read, especially if you're looking at your notes later. Does it make sense when you're plotting the points? You're just going to go through and plot them. Which, if you didn't buy very much gas, right, it shouldn't cost you very much. You only bought 1.1 gallon, it cost you $4. Versus when you had now at 3.3, which you if you're having to buy gas now compared
It's
to last summer, gas prices have gone up. It's getting closer to $4 a gallon, right? $3.60, $3.70, I'd say around that. Yeah, it's gone up hugely. Okay, what type of relationship does it show? And so if we were looking at this, what would you say? Positive or negative?
Positive.
Positive, linear, right? Strong or weak? Very strong in this case. So, if we are looking at that first answer there, I would say this is a strong, right? Linear, positive. Doesn't really have any outliers, right? The second part says describe your data. So I gave you some different options. Great answer. You get more gallons of gas when you spend more money. The more money you spend, the more gallons you get. Poor answer. When the X number gets bigger, the Y number gets bigger. You're just telling me about the X and Y. You're not telling me about the gallons. Awful answer. The dots go up.
There are dots.
That would be another two. So once you've looked at those answers, so read the four. Tell me, do you think it's positive, negative, or no correlation? And when you're thinking of these, you might want to think, what would the graph look like? Up in front, gentlemen. So, population of the city. So if we're thinking, oh, this is the population of my city, the number of people, right? Population of the city and the length of the name of the city. So the number of letters, right, in the city name. Do you think they should be related?
No.
No. This is like the number of letters. Do you think there's any relationship? No. There's the city of Fargo, which doesn't have many numbers or many letters, right? But there's quite a few people, right? Whereas Castleton, a lot of letters in the city name of Castleton, but their population is quite a bit less than Fargo. So it could be all over. Next one. Time spent running and the number of calories. So think of the graph this way. This is your time that you run. And this is the calories you burn. So your calories that you burn. If you just run around the block, you probably don't burn that many calories, right? So a short distance or the time it takes you, you just go around the block. Whereas if you go on anyone's doing the 10K or the 15K or the marathon, what's happening to your calories? So this one should be positive, right? I would like you to try and answer the next two. Negative, a mortgage is what you owe, hopefully over time. Some people take out a 20 or 30-year mortgage. Sometimes they're 15-year mortgage. That's what you owe the bank to buy your house. So definite negative. Okay? How about this one? Your height from age 1 to 18. So here's height over here. And this is going from year 1 up till you're 18. Oh, 24. Generally, we think it's going to be what? Positive. Now, are there times when you get to a certain height and you stay there? And some of you might have grown as far as you're going to grow, and some of you. So, like, it could be something like this, right? Then you grew 4, then you grew a lot, then it kind of plateaued, right? But it should definitely always be positive.
It'd just be weak, wouldn't it? It's tough to grow.
All right. So this is what your assignment looks like in the workbook. If you did not do 5A, please make sure you also do 5A and 5B.